the smart contract is being deployed. That is a constructor. And then it uses like the importance it has in smart contracts. Number one, it helps us to initialize the state of the contract, right? Um, and it also assigned ownership. It ensures security and what again? Increases security and trust for the smart contracts, and it affects gas fees in the sense that um, the more cumbersome your constructor is, the higher gas fee it charges. The less cumbersome it is, the less gas fee it charges. So constructors in smart contracts is very, very important because it is being run once. As I said earlier, it is a special function in smart contract and solidity development. So in summary, I just realized that constructor plays a very, very key role um, in in solidity and in smart contract because of the initial uses and importance I just stated. So from my end, that's in summary what I actually learned. Thank you.
All right, Jethro, thank you very much. That's very, very interesting. And thank you for like doing the assignments. I really appreciate. And that's exactly why you need constructor. Because I did the research too and added it to the HackMD file. Okay, explore just a minute, please. So I added the result to the HackMD file. I'm going to be sharing later, like towards the end of this class. So, Jethro, thank you very much. That's exactly why you need constructors. They are very, very important. Like initialization of state variables. Once you deploy your contract to the blockchain, and then you can use it. Like somebody was asking the other day if you can set the ownership directly from the state variable instead of using the constructor. You can, but for security reasons, you shouldn't do that. You should use the constructor to like set that variable. So um, hackers don't get easy access to your contract. So that's interesting. Thank you very much. Like Tech Explorer, you have a question, right? Or you also do the assignment. Please turn on your mic and speak.
He also did the assignments.
Okay, you did the
What I
assignment.
read,
All
what
right, go
I
ahead.
knew um, in constructor, what I read about constructor, I read that there are expression functions that initialize. Someone's talking. Can you hear me, please?
Yeah, I can hear you.
That the expression function used to initialize the contracts, and some of the things that are meant to be known about constructor is that it initialize and state variables, whereby itself like initial values of the contract variables. Like,
Okay.
and I also did some little practicals. I also did some little practical whereby I practice on ARC token, like ERC 20 token. I did a project on just a little Solidity project on like testing on constructor when I was doing my research. And also craft out a deployment example in that ERC 20 token. Also, I also learned that constructor is also perform the function of immutable variables, whereby you can assign values to immutable variables only once. And typical one thing they say typically in constructor, they are cheaper than regular state variables. The constructor they are cheaper than regular state variables. And also gas optimization, it optimizes the gas when running a code. It can move into like it's save gas compared to writing in its code in a regular functions. So these are the things that I can say I can remember.
Yeah, that's interesting. Thank you very much, Dr. Sparrow, for your time to listen. You know what? I am not going to share. I'm going to remove it from the file I want to share with you. I want the rest of you guys to also go and read about um, why you need constructor in um, Solidity smart contract. The last time I gave assignment for you guys to write a simple um, counter contract. Only 2 or 3 people did. The rest of you did not do. Yesterday, I dropped an assignment. Only 2 people. So I want the rest of you to read about it. So that next in my next class you explain what you understand, like why we need instructors. So I'm going to be sharing the file I want to share with you guys, but I will not include that why we need the importance of constructors in Solidity smart contract so that the rest of you do the assignment. So we let me know if you can see the remix ID. We stopped somewhere there first. We couldn't finish the other class, so we're going to be using the next 30 minutes to finish up. We have just few lines of code left to like explain, and then we'll move to today's topic, like is writing and deploying our first smart contract. So I was trying to explain constructor to you guys the other day, like 2 people already did that, why we need the importance of constructor. And this, can you guys see my remix IDE?
Yes, sir.
All right, thank you. So this is a constructor. Like if you we need constructors to initialize state variables once the contract is deployed to the blockchain, and we use it to set ownership of the contract. Like whoever deploys the contract is the owner of the contract, and we can also use it to like once you declare ownership or declare initialize state variables, you can also use those variables to modify to set modifiers to restrict functionality, to restrict access to some kind of functions to only the owner of the contract. So, and this is how you declare a constructor in Solidity. Unlike other functions where we need the keyword, the name, and invisibility, we don't need that here. We just use the keyword constructor, then the open parentheses can take multiple parameters. In this case, we are taking one parameter. We're trying to like initialize this the counter variable here. You understand? So here we are assigning parameter to the counter variable inside the constructor. We are assigning the parameter here, the call data. That is in the contract, whatever you input here becomes the value of this counter variable, this state variable here. So, and this constructor only read once, like get called only when once you deploy the smart contract to the blockchain. That's the only time this the constructor is called, and that's all. Set your initialize your variables, set ownerships, and the rest. Like in the case, according to based on what you guys just go and read about it. The rest of you that did not read about it, I believe I am happy that 2 people did the assignment and they understand what constructor is and why we need them, why we need constructor in Solidity smart contract. So here, next one we're talking about error handling in Solidity contract. So error handling, for example, if in your contract you have a specific amount you want to transfer, like you want a specific amount to be transferred, you don't want most of the time if you want to transfer Ethereum or anything, you don't transfer less than 0, you don't transfer anything below 1, right? Any token you want to transfer, you don't transfer below 1. So, and secondly, the input must not be empty, right? So you can check to see if the amount of Ethereum you want to transfer, the person, if somebody wants to transfer, is below a certain amount, there should be a message, right? So, okay, there should be an error message. So here, example, this, you can declare, you can handle error by like creating a function. Here is the for example. Yes, this is just a name. You can use any name. This is require example. You even require to handle error. So here is the function with the name of require example, and then there's the parameter inside for amount. So it is pure, it is public. This function is not a state-changing function, right? It's just there to check to make sure a particular error is handled. Let me put that with a particular task is met. So, sorry, it's Jenna.
Yes, sir, I have a question, sir.
Okay.
Yes, my question is that error handling now, is it that you have to put this function in every of your code, and if you automatically put it in your code, like every error will pop out? Is that what it is for? Because I don't understand what it is for. Hello, sir, can you hear me? Sorry, class, am I audible?
Yeah, you are actually audible. I think it's from his end again. Let me see.
So, sorry, like, can I come in?
Sorry, Christiana, what's the question, please? Sorry, I don't know. Calls keep coming to me.
Okay. Sir, can you hear me?
Yeah, I can hear you.
Yeah, so I was asking for that error handling now. It's a function, right? Like, is it that you put it in every of the Solidity code, it automatically brings out the errors in the code, or what is the use of the error handling, or is it for the front end? Or I don't understand that. That's why I wanted you to explain.
So I'm still trying to explain error handling, right? So,
Yes, sir. Yes, sir.
so this is smart contract. This is not, you have error handling in front end, right? But this one is for Solidity. This have to handle error in Solidity. There are ways to handle error in front end.
Okay, sir. So my question is, like, when you input this code in your contract, is it that it automatically handles every error? That's what I was asking, sir.
Every error, no, it's like you have to declare multiple errors depending on what you are handling, the kind of error you're handling. So this one is for input error. For example, this one is for input error. Like the minimum amount you want to send must not be less than 0. The amount must be greater. Here, the amount must be greater than 0, right?
Yes, sir.
So this doesn't handle every other error. It handles this input error. This is very input error. Transaction like input.
Oh, okay,
Whatever
sir.
amount you want to send, yeah, whatever amount you want to send. So you can declare different error handling functions depending on the kind of error you want to handle.
Okay, sir. I understand now.
All right. So to handle error, you need require this is a keyword, a special keyword in Solidity. Require. This requires that the amount of Ethereum you want to send must be greater than 0. Understand? So require takes 2 parameters. First, the actually conditional, right? Yeah, this is the condition. And then the second parameter is the message, error message. If this is true, it's the transaction will just go on and execute the transaction. But if this is false, like if the amount is less than 0, and then the second parameter will like fire, you get the error message. Do you guys understand this?
Yes, sir.
All right, I'm getting a long answer. All right. So handling error, you create a function. Using parameter, you create a function, and then function can take several parameters depending on how many errors you're trying to handle. You can create more required can create, yeah, you can use multiple required. So in this very case, we require that the amount of material we're trying to send will be greater than 0. Else, this is like if else. If the amount is greater than 0, go ahead. Else, like here we're saying if the amount is greater than 0, if else in JavaScript, right? If the amount is greater than 0, go ahead. Else, if the amount is less than 0, then throw this error message. For those who are coming from JavaScript, I only know JavaScript, right? So I don't know Python, and so that's why I'm always making reference to JavaScript. So the rest of you, please don't be angry about that. Yeah. The comment say it will continue execution if the amount is greater than 0, but if the amount is less than 0, and then it will throw this error message right here. You can also handle error by using assert. This is require example using require. Then we have 3 ways of handling error. We have the require, we have the assert, and we have the reverse. So for the require, for the assert, you know how to assert. You assert that if something should be this or that. If not, something else should happen. So using assert, this is mostly used for internal errors, right? So here you can see here we are taking 2 call data. So this is a mathematical operation, right? So and here we are returning 256. I told you this, if you don't declare the site, it will default to 256. So here we're saying these are local variables, right? This is a local variable. We are adding the 2 input variables here, 2 call data here to give the result. So we're saying x, the first input variable, the first call data, minus y, the second call data, and whatever the result is the value of this state variable right here, this local variable right here. So we assert that here we assert that result in this case, results should be less than or equals to x, depending on what the value of y is. I don't know if you guys understand. For example, let's assume the value of x is 5, right? And the value of y is 0. Value of x 5, value of y 0. That's in the input. If I like, I will deploy this contract and we'll play around with it. But let me just explain first. Let's assume the value of x is 5 and the value of y is 0. And then when you minus y 0 from 5, here we assert that the result should be either less than 5, that is, you minus a higher value than if y was greater than 0, then we should have less than 5. But if y was 0, since y is 0, we should have 5 here, right? That's what this is asserting. We assert that the result should be either less than 5 in the case where we subtract a higher number than 0 from 5, we should have less than 5, depending on what we subtract. But in the case where we subtract 0, where y is 0, then we should have 5. I don't know if you guys understand that. Okay, we have a question. Emerson, please go ahead with the question.
Okay, is it part of the syntax that it must be either less than or equal to, or we can change that particular part of the code? Like
you can
where we
change
have
it. But here we are checking. It is like to me it is recommended you put it this way in case of any error, just to avoid any error. Understand? Yeah.
Okay.
It should be like this because just like I explained, in the case where y, the value of y is 0, then we don't expect to have less than. We don't expect to have less than. The result must We don't expect to have less than 5, right? We expect to have at least 5. That's why we should always like declare it like this.
Okay, sir, that is noted.
So this is like recommendation, like just like I don't know. It depends on your preference, right? But for me, I'll always go like this, just to properly handle the error. And this should never fail with proper inputs. If you like all the inputs are proper, yeah, correct, this should not fail. So I want you guys to understand the difference between required and assert. This is asserting that this should be like this. If not, it should fail. This require takes 2 parameters, as you can see here. This is the first parameter and it's separated by comma. And this is the second parameter. If the first parameter is true, the execution, like it continues the execution. But if it is false, and then the second parameters shoots, fires. But in assert, just have you assert that this should be like this. If not, it should just in assert, like assert already knows the result. So, but in parameter, we don't know what is. We don't know what the amount is, but the amount should always be greater than 0. But in assert already know the answer. Understand? But so as you can see here, the result should either be less than 5 or less than x or equals to x. Since you are subtracting, it should never be greater than x unless you're adding. So reverse example, which is the last one for this Tuesday's class, using revert. Using revert, this is how you declare using revert. This is just a name. You can give it any name. So here there's a bool. As you know, all of Boolean is either true or false. Understand? So set to pure public. This is just handling an error. It doesn't change the set of the contract. So here we are saying if condition is true, because here we are declaring a Boolean value, and this is already set to true. So if the condition is true, it should revert operation. It should revert operation with this error message operation cancelled. Else, if the result is false, and then it will cancel. It will like the operation will continue if the revert is for what am I saying? It should revert if condition is true, but if condition is false, the operation will continue. Does that make sense? No answer. Jethro, you have a question? Please go ahead.
Yeah, not a question to be precise, but if we can get practical examples of how this error handling will be, I think it will give us more insight. If you have room for it, but if you don't, we should. I think we can still go back and look into it. But it will be preferred if we have practical examples, because now using stuffs like X and Y, so people can be confused. But if we have a practical example where they see it working, I know that it will be better.
I understand, yeah. I understand. Okay, we're using the constructor here, so we need to set the value of counts, initial value of counts. So let's say initial value of counts is let's try first. So did you guys see what happened? So I just deployed this contract, but for you to like deploy the contract, you need to set, while deploying the contract, you need to set, since we're using a constructor, I'm using it to set the initial value of count. So you need to set it before you deploy it. And that's what I just did. I set it with a value count 5. So that means if you come here now, you check counter, you should have 5. If you have 5. So we just use the constructor to initialize the value of this variable here. Okay, now let's for example. So if I try to send, now we're trying to like send a transaction, send some ether, right? If I try to put, let's say I try 0, will this pass or fail? Can you guys hear me? Hello?
Yes, sir.
Yes, sir.
All right. So what would be the result if I call this function now with 0, with amount of 0? What will be the result?
It will throw an error.
Okay. You see, there's an error. Sorry, this is not. Okay, all of them are like all the errors are shooting at the same time. Yeah. So I tried to call this function with 0. I'm trying to see this. Okay. This is for reverse. For example, I'm supposed to see, you're supposed to get this message, this error message, to show that you are not following the rule. Like you're supposed to call that function with value greater than 0. Let me clear this and call this function again. All right, here's the result. I don't know if you guys can see this. Here's this error. This error I highlighted. It's telling us that the transaction has been reverted to the initial state, reason provided by the contract. Amount must be greater than 0 because we are calling the function with 0. And here it requires that the amount must be greater than 0. Else, it should throw this error. And that's what we are getting. So let's say we try to call it with a bigger, let's try call it with 1. You see, now there's no error. There's no error, right? So the transaction went through. Please, if there's no noise in your background, just turn on your mic and like let's interact. But I'm not looking at this driver right now, so I don't know if you're raising thumbs up or raising your hand.
We are with you, sir. Don't
All right.
Yeah.
All right. So you see, the transaction went through this time around because we are calling it a value that is greater than 0. So let's go ahead and play with the other the other function. For example, the revert example. We should have three functions. We have the revert, we have the abstract. So the revert, okay, yeah, I'm looking for this very much. The abstract. Okay, let's say the value of x here. Let's set the value of x to be just the way the example I gave initially, and the value of y to be 0. And when I call this function, I expect x to be 5, the result to be x, which is 5, right? Because we minus 0. So this is why we are setting this. We are using this, it should either be less than or equal to 5. In this case, it is equal to 5 because what we subtract, the value of y was 0. So we subtracted 0 from the value of x, which was 5. Then we got back our 5. So let's say x is y is a bigger number. Let's try one. Call the function again. And the result is 4. You can see, just like you see there, the result should never fail if proper input, if the input, like if you have proper input, So here we enter proper input. So let me give it a higher number here. Let's try 6. Let me clear this. You see there's an error because now it reverted, right? So we did not specify any error message. In fact, I don't think you can specify error message. So it reverted because I think the result should be less than or equal to x here, but then we are subtracting 6, a higher number, from a lower number. So it gave us 0, but there's still error occurred because we are subtracting a bigger number from a lower number, right? So the result is still lesser than x, but then there's an error. So
sorry, sir. That assert. I don't know, but my question is, when we use this result less than or equal to x, which is 1, which is minusing 6 from 5, the value will be 1, which is still lesser than 5. So why did the thing still return this and revert error instead of it running?
we are minusing 6 from 5. The result is not 1. The result is negative, right? The result is negative 1.
But even though it's negative 1, is it not still less than x?
This is solution. So it's giving us 0 and then this.
Okay, it doesn't take negative.
So, okay, yeah. So we're using unsigned integers. And unsigned integers doesn't take negative. I explained that, right? So it cannot give you -1. So instead, you give you 0, then throws an error. I think you are using signed integers, and I believe you can get your -1. I don't know if you guys understand. The result here is unsigned integers. And like I said earlier, like you said the other day, it's up somewhere up here. Unsigned integers only start from 0 to 152, like depending on the size of the variable, the data type. So we're using unsigned integers, so you cannot get -1, you cannot get negative number. Does that make sense?
Yes, sir.
Yeah.
So
Yes.
my question is now, if we want to get negative, we have to make it int, right?
Yeah.
Okay.
Yeah. Okay, now for the revert, right? And yeah, there's a question, right? Okay. I'm trying to call this function to see what do I like to call this function now. Let's see. Function, so let me, I don't know if I use yes to call this function. The provided value is invalid. The provided value is invalid. Sorry. Did you guys notice what happened? You guys notice what happened? When I called the function with true, it reverted, right? The transaction reverted. But when I called it with false, because here we're saying if the condition is true, it should revert. But if the condition is false, it will fire because the transaction will go through. So when I called the transaction with true, the transaction reverted, right? It gave us an error. Let me try it again so you see. But before that, you can see here that the condition is false, so the transaction went through. There's no error. There's no error anywhere here. So if I try to call it again, let me clear this. If I try to call it again with true, like making the condition true, I call the function. You see, there is the transaction didn't go through. It threw an error. The action has been invited to the initial state. Reason provided by the contract. Operation cancelled. This is the error message here. Operation cancelled. Why did operation cancel? Because the transaction, the boolean here, the boolean value here is true, which is not supposed to be true. So the operation cancelled because the boolean value was true. Does that make sense? Like it's right. You said we should. You're the one that said we should show examples, right? Hello, guys. I don't think you guys understand.
Yes, sir. We would like to see the example to give us more clarity.
Sorry, you have not been following. I just showed you an example, right? I just showed you an example. Okay, let me start again. Okay, let me just try. See, now that the condition is true, here you are saying it should revert if this condition is true. It should revert with this error message. Emerson, are you following?
Yes, sir. Absolutely.
It should revert if the condition is true. But if the condition is false, the transaction will transaction will fly to execute the transaction. So now we are setting the condition to be true, and we're calling the function with that. What are we getting here? We're getting an error, right? We're getting an error message. It reverted. Why did you say the transaction has been reverted to the initial state? The reason provided by the contract, operation cancelled. Operation cancelled. And that's what we specify here. If the condition is true, it should revert to this error message. Sorry, 1 minute, 1 second, please. So that is we are stating here that if the condition is true, it should reverse with this error message. But if the condition is false, then the transaction will execute. So we call the function with true, and that's exactly what happened. It gave us this error message, operation cancelled. But if we should call this same function now with a different value, Boolean value, let's say false, which is now the execution will fly. Let me clear this. See, there's no error message. This time, the transaction went through, right? Emerson, did you get
Yes, sir. Yes, sir. Now I get it.
You're not following.
No, I get it, sir. Because my initial confusion was that in JavaScript, like the parameters are usually within the block of code, but it seems for Solidity is by the side, and if it's set to true or false, then it determines the kind of whether we'll see an error message or not. So I get it, sir.
Okay. I think you can compare the if else in JavaScript to the require example here. The if else in to me, I don't know, to my understanding, I don't know about you, but to my understanding, I can only compare if else in JavaScript to require in Solidity.
Yeah, that's right. That's
Yeah, if this is true, continue. If it is false, then else, then throw this error. So can we move further, like move to today's topic, or do you guys have any questions? I don't know. I'm supposed to. I think I should create a HackMD file with all this, and then send it to you guys. I will do that after the class, so you can because most of them have their explanations inside commented out. So let me uncomment this. So most of them, all these ones I commented out, they are like causing my code to shout one way or the other. So I commented them out. So most of them have their explanations or definitions inside. So I'll convert it to a HackMD file and share it with you guys. I don't know if I can share this. Should I drop this link and see if you can open it like this, the way it is? So you have all this.
Sorry, sir. I think maybe you can maybe like how do we call it? Push it to maybe GitHub. We can get it from there now since it's
all right,
Linux.
all right, that's good. That's nice. I'll do that. I'll push it to GitHub later. Yeah, share it with you guys. So can we move to today's topic, which is yeah. Okay, writing and deploying your first smart contract. That's today's topic. So, So let's move to today's topic, right? Since you guys don't have any question. So we'll create another file. We're going to be writing and deploying our first Solidity smart contracts using the Remix IDE. So it's going to be a very small. Although I gave you assignments on Monday to write a counter contract where you have three functions. One to increase, you have a state variable count. Have three other functions. One to increase count, one to decrease count, and one to get count. Only 2 or 3 people did the assignment. Well, and those people now know how to write smart contract. What I'm going to be doing will not seem new to them, will not seem strange to them. But those of you that did not do, please pay attention, because after today's class, I'm going to be giving you assignments to write and deploy a smart contract for me. So I think it's a norm, it's a convention. Assignments are always harder than examples, right? That's how it has been, right from primary school. The teacher will give you a simple example in class, and then they'll give you one hard assignment to go and do. So I'm going to be giving you very hard assignments, harder than what I'm going to be showing as an example. Just kidding, sure. It's not hard. Solidity is not hard. So let's write our first smart contract. So I'm going to create, so you have example folder here. So inside there, I'm going to create a simple let's say a simple storage contract, right? Need something very simple so you can understand. Yeah, let's try simple storage contract. So inside here, I'm going to create. Please, I want you guys to put along. So as I'm doing, also be doing the same thing. Yeah, okay, just pay attention. Pay attention. So let's call it storage contract. All right. So like I said, whenever I want to write a smart contract, first thing you need to declare. I'm going to ask a question on that. Who knows what you're supposed to do first? You're supposed to do something first. All right, John.
Okay, we are going to write the version we are using. That's pragma solidity. And the
how do you write that? You start with.
We start with pragma, right? Then solidity
Version.
0.8.
You're right, but that is not the first thing to do. It's something else before Manuel.
Okay, you first start with declaring the license. You write SPDX license identifier, then MIT.
Exactly. Thank you. Thank you. And thank you. Who was the first person to answer? Thank you too. All right, so let's continue. You write it in a way that looks like you comment, like a comment. Sorry. Right. So in capital letter SPDX. Right. license. Identifier, sorry. What is I'm looking at? And then what we mostly use the MIT. Then your SPDX license, identifier, MIT. And then this is where you specify the version of Solidity you want to use. So we are using version 8.0 above. Sorry, version 0.8 and above, not 8.0. So do I get this? Looking at that symbol. Okay, yeah. So 0.8 point. Let's say zero above. So we're using from Solidity version 0.8.0 and to the latest. Any version above this can work, but any version below this cannot compile our code, right? So the next thing to do is to declare your contract. Let Solidity know that this is the contract, right? So we use what is it called? Pascal case for any of the contract, where the first letter of every word is capitalized, right? So this is our contract. Our contract name, simple storage, and then we open curly brackets. Every code inside this curly bracket is part of the contract. So since we are writing simple storage, first thing to do is to declare the state variables, right? And it's a simple storage, so we need names and state variable. I'm going to make it private. You all know visibility, right? You know what this is. This means that only this contract can access this storage. I don't know if you can hear me clearly. I'm a bit far from my system. So only this contract can access this variable, this state variable.
Yes, sir, we can hear you. We are seeing it here.
Okay, so we call this stored number. See the difference here now. For the contracts, I'm using Pascal case. The first letter of every, we have two words. We have two words here as the name of the contract. So the first letter of each of the words is capitalized. But for the state variable, sorry, let me close this. For the state variable, you need to always terminate your code with this semicolon. Else you have, just like I was having now, the code of shouting. So as soon as I added this, stop shouting. So here the first word store starting with small letter, but then the second word number started with capital letter. If there's another word after number, the first letter should also be in capital letter. This is Snake case. This is Pascal case. That's the norm in Solidity. That's the convention in Solidity. So all constant variables, they are constant variables. All constant variables. Constant variables is something like in JavaScript. Variables that don't change, you cannot mutate them. They are immutable. You cannot change them in the future. So they are declared in capital, all caps, capital letter. Understand? So normally at this point I was supposed to declare event, but I did not teach event handling because I am not. My next colleague will take you on event handling. So we will declare event here. I just tell what it means. Then the next person will break it down simplest form for you to understand. So we declare events. So by to declare events, you just event and you give it a name, right? Sorry, look at letter. So you give it a name. Let's say here you after case number stored. Yeah, let's say number stored. So what we need the you open a bracket. Sorry, you open the bracket. First, we need the address of the person that stored the number, right? The sender, the address of the sender. So the address and we index it. Don't worry, my colleague will explain what this is about. So we index the address. So we are where is it from? So this address is where the number stored is from. This is not complete, that's why we are getting this error. As soon as I complete the code, it will change. So and then we need a unit. I'm just going to make a change. This should be a new number, whatever input the number is. Still can make this correct. Okay. I'll not explain this much. My colleague will explain to me else. So now we need a function to store the number, right? So function store number. Let's call it store number. The difference between these two words, this is stored number, past tense stored, and this is store number. This is store number, so there's a difference. And this is the new number, they're not the same. So function store number, we need a parameter. Because the function that will change the state, this function that will add to whatever is here. Here initially this is 0, but now this is 0. So this function now will add increment. This is more like a counter contract, but it's friendly. So we need to open parentheses and then we need units, not units. We need the units 256. So here, let's say number, right? Notice how I'm using underscore to name the input variable. This is to like differentiate them between, for example, you can still have another variable called number outside, like state variable or local variable. But then you need to differentiate. Anytime you're like writing the parameter, it's a convention. You always use this underscore to start the number of the name of the parameter to differentiate it with any other state or local variable. So let's make it public because the public, it should be a public function, so everybody can see and call it. Now we are going to assign the value, whatever you put here, we are going to assign the value of this stored number. So to do that, you come here and say stored number equal to the value.
So if you can view it and zoom in a bit, please. We are getting it very difficult to see.
Is that enough?
Very cool.
Right. Okay. Let me explain this. For those of you that were not seeing the first day. So here, we are declaring the license. To write it the way that it looks like a comment, And here we are declaring the compiler version we want for our Solidity smart contracts. And then we're using anything above from this version above. You can use below, But here we're using from this version to the latest. Anything above this can work. From this 0.8 to zero point 0 can work. Above can work. So here we are declaring the contract. To declare contract, to write contract smart Solidity smart contract, you need to declare the contract. And then you give it a name using Pascal case. And then you open this curly bracket. Anything inside this curly bracket is part of this. Yeah, thank you. It's like you're just joining us. Please go ahead.
Good morning, sir. What my question is,
Hello?
Can you hear me?
Sorry, yeah, it's not clear.
All right, can you hear me now?
Yeah, I can manage.
Okay, and my question is, the above you put there, that means if someone should be running this smart contract on his system, maybe
Sorry, can you I don't know if you're using earpiece or something.
Continue, let me get my mic.
I don't know if you can just write your thing. Let me read it. Hello? Okay, you just send a message, call message so you can. Okay. Like I was saying, you need to, if any code inside this two parentheses, these two curly brackets, is part of this contract, is part of the body of this contract. Anything outside cannot be you can declare other contracts outside this contract, you can write another contract outside this contract and make them interact with each other. But anything inside these two parentheses is part of this very contract. Any variable you declare inside this two parentheses that is private can only be accessed by this contract. If it is internal, it can only be accessed. Sorry. But somebody saying something. All right. So if the variable is internal, only these contracts and derived contracts can access these variables. So so let's continue. Now, after storing a number, you need to emit the number. This is where this event emission comes in. You need to emit the whatever. You need to emit events, yeah. So you emit this is you emit as the name of the number stored, right? And then we need the message of sender. Whoever emitted the number, the event. So here we use mfg of sender. And then we emit number. So the number here should be that's it should be the value. Right. So now this is the smart contract. But now our third number here is private. It means we cannot, let me compare it, I'll show you. We cannot see it in the blockchain. It's not visible. That's in this thing, so we can. So stored number, if it's not visible, we cannot see it. So we need to create a function, a data function. I'm supposed to ask a question on that, not we need to create a function. I was supposed to ask a question on that to see if you guys understand, but I already said it, so let me just continue. Video get stored number, right? Stored number. Here we are only returning. There would not be any call data. So make it so sorry. I want to understand if you guys understand visibility. So here, what should you do here? You just want to get the value of this variable here, this variable here. So we already declared the function get stored number. So what should be, yeah, it should be public because you need it to be public. You need to access it even outside the contract. So after public, what should we add to make it data function, not a data function? Anybody can answer that. Can anybody answer that?
So maybe return.
So view return unit. View return unit.
Thank you. Like I can't know. Thank you. Person. You view. Let's make it public because we need to be accessible. Then you view and then you return. So what are we returning? Let me close this. Returns in 256. So here we say it should return. I don't know since when did she start suggesting if AI built in this thing that is suggesting this thing. I don't know. I'm going to take advantage of it. So let me explain this contract for you. Here we have a state variable which is private, which can only be accessed inside this contract. So this is a state variable, stored number, it's a unit 56. So we have events. The name of the event is number stored. Should emit the address, should like index it. So it should also emit the new number. These are like variables. There's no assignment on it now. You only assign value to them when you are emitting the event. So now we are assigning message of sender, whoever is sending this to this address from, and now we are assigning this call data, whatever inputs the sender imputes becomes the value of this variable right here. You can also call these local variables because they are defined inside this emit function, this event function. Sorry. Now we are emitting this event here. So this function now adds to this very number, to this very variable. Function stored number adds whatever you add here, whatever input here to this variable. The function is public, and then this is where you're adding. This is where you're adding. We are saying stored number, this variable here, should become whatever the value, whatever the sender adds here, input here. Stored number should become that. So and now we are emitting the event. And now since we cannot see this, we are setting another function to get this value. So I need to delete this compile. So here we come and let's delete the initial one because we already changed. Anytime you make any changes, you have to redeploy. Once you have deployed a smart contract to the blockchain, you cannot change. The contract becomes immutable. So if you make any changes, you have to redeploy. I don't know if you understand that. You have to redeploy again. So we are deploying again, and now we have the function. So like I said, initially, if you don't give it any value here, it will default to 0. So now we can access this. Here it is private, but with this function, we can see what is inside of here because we are returning it here. So if you click on get stored number, you have 0. So let's add to that. We have 0. So let's see, we add 2 to transact. Let me see. What's happening? Yeah, transaction was successful. So if we click on this button again, this one, call this function again, we should get the value of this should become 2, right? Because that's what we are stating here, that whatever the value of this is should become the value of stored number. So this is our first smart contract officially. The other one was an assignment, so most of you did not do it. So this is our first smart contract. Is there any question? Do you have any questions?
Yes, sir.
Okay. Let's go ahead with the question. Somebody raised hand just now. Let's jump here, right?
Okay, sir, can you go back to the code, sir?
All right. Yeah, now I can hear it clearly. Like you are using something else.
I was using AirPod, so now I'm using PC. Aha, this program Solidity.
Pragma.
Yeah, you said the version is supposed to be higher than either 8.0 or higher, right? 0.8.0 or higher. What if someone is using a lower version? He won't be able to see this code or what?
You cannot compile this code.
Okay, he can't compile this. But if someone uses a lower version, that means someone using a higher version can compile the code.
Yes, that's what you're speaking here. Anybody, any compiler version, any Solidity version above, from this above can compile this code.
Okay, but okay, I understand. Thank you very much.
So any other question? Because I'm going to give exercise right now. Somebody's raising their hands. Yeah, Adela.
Sorry, sir. It's about that event and a meet. I just want to ask, what does it really do, or when do we really need to use it?
Yeah, like I said, I am not supposed to take you on events, but I just showing you to write a smart contract, like to write a well-structured smart contract. You need to emit events, always emit events. Let me clear this and then I'll show you. I need to call this transaction. So whenever we call this function, it should emit here. So I just call that function store number here. So okay, this is the event. This is the event emitted. You can see event stored number. So what? I just want only this function. So this is the event. Right. So
Okay.
So this is the event. We are asking it to, like, whenever the user store any number or whatever this function, this is state changing function. Whenever this state changes, whenever this function is called, it should tell us who called the function, right?
Okay.
Yeah, who called the function? In this case, the message sender called the function. This is the address of this contract. This is the person that called it. This is the address of the person that called the function. Now they say here from who? From to telling you from this address. This is the address, and the value of this address is the message of sender. As we know, we have not set the message was sent out to be the owner of this contract, like the person who deployed the contract. Yet we can do that with the constructor, and then we create a modifier to modify the function to make sure only owner can call this function. But now anybody can call this function. But now this is coming from the message of sender, the person that called this function. This is the address of the person that called this function. And now, what is the person? The person added a number. So, what is the value of what is the new number? What is the value of the new number the person added? And now we are saying this, whatever the person added here, whatever is called, this call data, the value of this call data becomes the, if you emit it, it becomes the value of this new number here. So you should tell us what is the number, the value that the person added. And now, since we added 2, it's telling us this person added 2. This is the person that called the number. They are called the contract. They are called the function. And this is the value the person added. First, you declare events, and then you emit the event wherever you want, inside whatever function you want the events to emit.
Okay.
Yeah.
Thank you.
You're welcome. So, any other question, please? You have the whole time. You still have more than an hour. So, I'm going to give you guys an exercise to write.
So I have a question.
Okay.
So you said you are not going to be explaining in depthly what events are. So I don't know how are we going to be able to do the exercise.
So you don't necessarily need to emit any events. I'm just showing you how to like declare proper contract. Your next class, I believe my colleague will explain events in details to you guys. So just then. So you can write you can do my exercise without, or you can still follow like the example I gave you. Just close this.
Okay, sir.
So you can just follow this. You see, I'm going to give you a very simple contract. This is a very simple one. I'm not going to make it harder than this. This is similar to what I'm going to give you. I don't know. Or should I just let you guys work more on this? No. I want you to write something. I want you to write and deploy a smart contract and explain it to me. I want your contract to compile and I want it to pass. I want you to play around with it. So I just wrote my own contract. You guys write your own contract now. So for those of you that I don't want to give you what I gave as an assignment that day, two people did that. I'm thinking of what I told you guys what table means, right? In a function. So if you guys can write a very simple smart contract, a payable contract that can receive Ethereum, it is not hard. It's very simple. Just a few lines of code. I want you to write a payable smart contract. It is going to have a constructor because I want only the owner of the contract to be able to withdraw. Is it hard?
Sir, please, can you come again with the assignment? You were breaking. I didn't
Not
hear.
assignment, exercise. I want you guys to do it now.
Okay, sir, please, can you come again with the exercise?
Okay, I want you guys to write a simple payable contract that can receive Ethereum. You have to have a fallback function. In the case where Ethereum is sent with data, right? This is simple smart contract. We'll do all these things together. So, but I want you to write your own. I want you guys to write a simple payable smart contract that can receive Ethereum, and the contract should have a modifier to set. Should have the constructor have a modifier to set only the owner. Somebody just left. Only the owner can withdraw Ethereum. Solidity shouldn't be too hard for you guys. If you guys are finding Solidity is hard, I wonder how Cairo and Rust will be. Because Solidity is like the simplest one. That's why they always use it as like foundation, set foundation. Solidity is very, very simple. I don't know Cairo that much, but I know Solidity to some extent. That's why I feel Solidity is simple. So please, it is very smart, like simple thing. Or is it too much for you guys?
I
No, sir,
have
let's continue.
I have a suggestion.
Okay, please go ahead, Jethro.
Yes, sir. It's not that we are scared of the assignment or it's too hard to say, but some of us are like some are actually using their phones
Oh,
to join the class. That's number one. Number two, I'll speak for myself. I was absent in some of the classes, so I'm trying to still set up my workspace in order to follow up and do stuff. But if others are ready, they can still do it so that we can still learn from them. Yeah. But this can actually be a very good way to start by giving us this as an assignment so that we'll take our time and do it and then give you
okay. For the exercise, let me change it. I'll give you this very one as an assignment. So we go through it on in my next class with you guys. But for the exercise now, I want you guys to write a simple counter contract for me. Okay, the counter contract should have a state variable, right? Counter. And then you should have, yeah, if you feel like emitting events, which is not necessary, but I just explain how to emit events. If you feel like adding this, it's added advantage to you to show that you understand, you are to understand. And then you have a function to increase count, you have another function to decrease count, and then you have a function to get count. And I want you guys to make sure only the owner can decrease count, can increase or decrease count, but anybody can get the value. Right? You have state variable counter. This is optional. And then you have a function to increase, you have function to decrease, and you have another function to get. So the increment function and decrement function should only be called by the owner of the contract. That's whoever deployed the contract, message the sender. That means you need a constructor. I already like explained that. So please let me type it in. Sorry, please. I don't know how to type fast. Simple counter.
So as you are typing, let me just ask a simple question. Like this Solidity is more or less like Java codes, right? Java. It's the same thing as Java.
I don't know Java.
Because of this closing of statement, whatever statement you or function you create, you have to close it with your semicolon. This semicolon thing. It's just like Java and Java and
JavaScript. Yes, something in JavaScript, but don't know about Java. I did not explain Java.
It's like TypeScript or JavaScript.
Okay, yeah. So
Because Java is also statically typed like TypeScript.
okay. A state variable. With three functions. One for increment, You see, this for, I think this for is a keyword in, see how you colored it. It's a keyword in, I'm going to comment this right up out, so one for increment, one for decrement, and one yeah, the current count. So write a simple counter contract, right? Write a simple counter contract with a state variable, three functions, one for increment, one for decrement, and one to get the current count. Sorry, add a modifier. So I don't know if you understand this. Write a simple counter contract with a state variable. Let me say private state variable. Let's put it private. Private state variable, three functions, one for increment, right? One for decrement, and one to get the current count. And then use the modifier to make sure only owner can change the state, the contract state. I believe you understand what this means. You have to like put it in this, use this language to see if most of you understand what I mean. Like I want only the owner to be able to change the state of the contract. Are you guys with me? So we can do this, right? I want us to do it now. I want you to write your first, I want you to write and deploy your first smart contract, and then I will give you assignment.
Sir, please could you put back the question? I'm trying to copy the question.
All right.
Yes.
Let me drop it for you guys. Yeah, I mean, please go ahead. mean, you have a question,
Sir,
right?
please, the assignment, are we only to share it, or are we only to share it through the screen by our sharing our screen, or are we to push it to like GitHub or something like that?
Do you guys have GitHub account?
Yes, we have GitHub.
Let's see what we have. This 1 hour. This is a very simple smart contract where we can finish within 5 to 10 minutes. A few people can present to me, let's see. Because if I tell you that I'll have time to go through your GitHub, okay, I think maybe the sub mentors will have time to go through your GitHub and check it. But I want few of you to present. Let's see. So just use the next 10 minutes to write this the contract. Once you are finished, you let me know. Right? Okay. Once you're done with your own, let me know. How many of us are doing the assignments, please? We are doing the exercise. Let me know. Okay, Johnson, Christina, John. All right, Junior. I think about 4 people are doing the assignment and the classwork. Fabiola not because
I'm with you, but my laptop is down. I'm trying to do a little, but my laptop is almost down. So I'm with my phone.
All right. How about Aminu, are you with us? We have, including myself and the two sub-mentors, we have 18. So we have about 15 people in the class. And so far, only 4 people are doing that classwork. Take Explorer, reading the classwork.
I'm done with mine, but I'm in a noisy environment. Let me just present my own.
Sorry, somebody say something, right? What was that?
I say I'm done with mine, but I'm in a noisy environment, but I can just present it, but I'll not talk.
All right. Okay. Let me stop presenting so you
I'm also done with mine.
So can you hear me? All right, sorry, please. I call coming to my phone again. So I've stopped presenting. That was Tech Explorer, right? Person that said I want to present. So please go ahead and present. It's Tech Explorer still with us.
Okay, I'm done with mine.
Okay, I don't think take a sprite to it. Please take a sprite. You can go ahead and do your presentation. Okay, that's up. All right. Can you expand your terminal? Like expand your terminal a bit. I mean this where you log this place where you log, just raise it up a bit. Yeah, yeah, yeah. You can raise it up a bit, expand it a bit. By dragging it up. Yeah. No, 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 not there, not there. Yeah, that line, yeah. You can drag it up from that line. Okay, yeah. Wait, just let me walk through your code. Yeah, your code is compiling and transactions are executing. I just want to go through your code. I'm seeing there's a mistake in though I don't. The only problem I'm seeing is the event. That's no problem because I did not issue event, so it's fine. That's the only issue. You're not like and there's no modifier to set the whoever deploys the contract to be the owner of the contract. Okay, I'll come to you, please. So please go up a bit. Let me go through your code. Contract counter, public. You're supposed to make this state variable private. That's what I said. And initial value is 5. Okay. So function increments. So nope. This remove the events. It's events. No, it's not properly declared. So you take out the events. Just it's optional though. So here we're increasing, then count plus equals to 1. We use plus plus instead. That's equal to 1. I already give it a value here. So we use plus plus. Count plus 1 or count plus plus instead of plus equal to 1. Hi. That's supposed to explain this. Wait, okay, your code is fine. Just you tried, but the event emitting is where I have a problem, and you're not like using a constructor to initialize this to set the owner as the whoever deploys the contract to be the owner of the contract. So it's fine. You did a good job. You just wrote and deployed your first smart contract. Congratulations, Tech Explorer. Thank you very much. So there was somebody that notified me first before this. Son of Almighty, right? So you can stop presenting, let somebody else present. We still have time. Son of Almighty, please. I like your name. So son of, you can present, then Akanemo will come with this on. Check Explorer, you did a good job. Thank you. I'm clapping for you here. Let me adjust this. Oh, yeah. You did a good job. So the next person is son of, let's see, it was I just so son of, please, if you're ready, you can present. Let me see your work. Let me see implementation. Okay, I don't think he's there. So I can't even Johnson, please go ahead and present your first. Hello, Johnson.
Yes, sir. Yes, I want to share my screen. Yeah.
All right, all right. Okay, after Johnson, Christiana will present. Can you guys see my screen? Oh, sorry. Okay, I'm not sharing. Sorry. If I just took like two.
So can you see my screen?
Yeah, I can see your screen.
Okay, so this is mine here. Let me zoom up.
Yeah,
So
zoom in
can
a
you
bit.
see?
Yes. Please play your terminal. Play the terminal. Let me see.
Okay, this is my terminal. Are you seeing it?
Yeah, this is your terminal. So I
Yes,
want
sir.
you to clear by clicking on that. There's a button. Yeah, yeah. Clear. Okay.
So this
So,
is
okay,
the size.
all right. Yeah, you already deployed.
Yes, I've deployed and I've tested it both with another wallet address, account
Okay,
address.
let me just go through your contract and see. Okay, you declared the license and the
Yeah,
pragma.
sorry.
No. Go up. I want to see everything. Okay,
Okay.
you have your contract counter and you're using version 0.8.17 upward. Interesting. So you have your private counter number
Yeah.
and then you have address. Okay, you have a still level of address and then you are emitting emit number. Okay, number changed. You have address, value, string action. Okay, let me see what's will be the value of this. Okay, your constructor is coming after the modifier. Okay, you
Yeah.
have a modifier on owner, you modify only owner can modify counter. Okay, good. You have a constructor. Constructor is initial value, and then you're setting counter to initial value. Okay, yeah, nice, interesting. Owner is and then function only owner. Interesting. Only the owner can increase this. Yeah, that's nice. And then you're emitting number change increased. Wow. But, uh, this return is not
Sorry, sir?
you decrementing these returns. I don't think this really.
No, I did the return because I want when they click on the decrease function, let it in my coded output. It should show in the transaction details. That's why I use the return.
All right. All right. So now we are getting this in function to get for the few return count number. Yeah, this is absolutely perfect. Yep. So Johnson, right?
Yeah.
Yeah, this is good. This is perfect. So congratulations, you just wrote and deployed your first smart contract. This is to me 10 over 10.
Yeah, thank you, sir.
Congratulations. Yeah, thank you very much. So Christiana, yeah. She
Yes,
did it.
sir.
You did it. So Christiana, please go ahead and present to us.
Okay, I'm coming, sir.
So after Christiana, Emmanuel Usman will present. Son of is not back yet, right? So I'm loving this. I feel encouraged. I feel happy. You guys are learning.
Sir,
Trust me.
can you see my screen?
Yeah, I can see from my end. So let me go through your license, your Solidity version, nice one. And then okay, you have the question here. So counter contract, counter, you have a private state variable of count, of address. Okay, you modify it also coming before your estimate to keep the rest of the code if condition is true. Okay. Then like a different section, root constructor, and then setting the initializing the count, yeah, then increment you
Yes, sir.
the owner can increase, function decrease, the owner can decrease as one, and then function just count.
So this is what I was able to do from what I understood.
Yeah, but it's not returning the counts actually. If you click on this function, it will not return anything. You click on get count, let's say. Click on get count. Now it returns the count. That's true. But you're not returning anything inside there, so
Let me raise it up.
so wait, increase the count. Increase count, let's see. Now click on get count. You see? Because you're not returning anything. It's supposed to change.
Okay.
Just go back to your count.
I should go back to get count.
No, to the in the code.
In the code.
Yeah. Up down. Now inside the parentheses where it says return a value, I want you to return count. Yeah. Inside where you committed this code out.
Yes, sir. Inside
yeah.
Okay. Okay, I was supposed to return count. Oh.
It's return count.
Yes, it's true. It was even showing me.
No, go back. Go to the remove the comments. Just remove the comments. Now enter. Enter. Click on enter before you write.
Okay.
Press enter. Now return count. So now we need to compile and deploy again.
Okay, let me delete this one.
Deploy. You don't actually need that.
Okay.
Yeah. Hold on, get count. Count should be 0. Yeah. Now increase count. Now get count again. You see, it's working.
Yeah, it's
now.
1. Yes.
Count.
Yes, sir. It's working. It returned 1.
Yeah, returned 1. Yeah, your code is right. Nice one. Congratulations, you did well.
Thank you, sir. So should I stop presenting?
Yeah, you can stop presenting. So send the journal, right? Okay,
Yeah,
Emmanuel, this one first. Emmanuel, this one first.
Man, I've been up for a while.
Yeah, Emmanuel was. Is Emmanuel with us? Emmanuel, this one.
Okay, yes, sir, I'm here.
Okay, please go ahead and present shortly before.
I'm using phone to connect, and my system is kind of low.
Okay, so you did the exercise, right?
Yes, sir.
Okay, can you present with your phone?
Let me check.
If you can, please go ahead and present. If you cannot, let John present. The idea is for you all to understand how to write and deploy your smart contract. And please, let me tell you something. Don't use AI to generate codes, please. If you must do that, make sure you understand the code. Understand? Make sure you can read and understand the code. Don't just okay, Emmanuel Usman left, probably network. Let's give him a minute. Don't just copy code from AI. It is not good for you. Personally. I'm not saying any of you did that, but don't do that. It's an advice. Yeah, thank you. Okay, I think Emmanuel is having issue with private network issue. So John, please go ahead and present. John, can you hear me? Send it, John.
Yeah, I'm about to.
All right. We have 13 participants, 13 minus the 3. I don't know if it will be still in the call.
Okay, so they take this
Let me go through the code. So we have the license, we have the pragma, Solidity version 0.8, we have the counter, we have a public variable. The assignment this assign the exercise frequency, you should make it a private, but it's fine. That's not a problem. And then you have address of owner. You're not specifying, you're not a visibility. This will default to internal. So this can only be accessed by this contract and derived contract because this is internal. If you don't specify the publicity, the visibility, it will default to internal. So we're using a constructor, it's setting the whoever deploys the contract to be the owner of the contract.
Yes.
We are increasing counts and increasing counts by 1. Require owner equals to messages in that. Did you try this code? Did it work?
Yeah, it's working. This is okay. Let me get counts decrement. And when I change the address, it won't go.
Yeah, it will give you error because that is not the that's not the owner of the contract. So you cannot change the state of the contract. Yeah, I am happy that most of you understand what I meant by change the state. By changing the state, you use the modifying error, like the error message. Sorry, go back to your code. No,
okay.
wait, don't. By changing the state, you are using the simplest like you do not use modifier to create a particular error to like reusable error.
Yeah, I only use
you really require inside each of the function. Okay, this is this flag. So I think the conversion is to create reusable. So you have lesser lines of code, clean code. So you don't receive it. There is something we call dry. Do not repeat yourself in writing smart contract. So this is fine. Yeah, this is fine. Yeah, congratulations, John, for writing and deploying your first smart contract on the term. Sorry, on the Remix ID. So thank you very much. So I think nobody is presenting the right. So it's just to still with us.
Yes, I am. I am. Yes. I'm very glad to see my colleagues do this. I hope to do it.
I believe you can do it too.
Yeah, I'll do it. Thank you.
So guys, congratulations to all of you that just wrote and deployed your first Solidity smart contract on the Remix IDE. You guys, I'm impressed. and happy to at least is still are learning. Not that when you have questions you cannot answer just for the brain, something like that. So, don't understand what you ask, you explain to you. If I cannot explain now, the colleagues, what's needs to explain to you. So I feel I was going to give assignments for those of you that have not set up your space. Okay, like they already taught you how to set up space for Solidity smart contract, right? For Nikon. So you need to set up your space and then do that. But all my lessons I'm going to be using for the next class, we're still going to use the Unix IDE. But for the final class where we start the project, we use the local IDE, which is the it's not right what's it called? VS Code. The VS Code. So I don't know which one you're using. It's me. I'm using VS Code. So we're going to be using our local IDE code editor on the final day of my class, which is the class after the next one, which should be after Easter. So I said I'm going to be giving you assignments to work on. You write a simple table. I want everybody to do it. Please, I beg you, but try. Do what you can do. Do not use any AI to generate the code for you. Even you are going to explain each line of code to me. I know I may not be the one to assess this assignment I'm giving you, but I'm going to ask questions based on this assignment next week when we meet. Or not really tonight. So you explain each line of code for me, what each line is doing. I'll that's how I'll know if you wrote the code by yourself or AI generated the code for you, right? So please, it is for your own good. So if you know how to write better code, cleaner code by yourself, it is fine. So please, I don't know. Is there any question for today? If there's no question, then I think we'll wrap up. Okay, question, Justin.
Sorry, sir. Sorry, you just talked about the assignment. So are you going to drop it here or is on the dark section? Because some of us did not really get what you said that time.
Okay, I'll drop the assignment with the one of the iOS online, right? I'll drop the assignment. I will give you the assignment on WhatsApp, via WhatsApp. So I'll write it down how I want the assignment to be, all the features of the contract you're going to write, and then I'll give it to I will send it to you via WhatsApp, right? And the submentor, the submentor available, either it will be or I am. So before the end of today, I'll drop the assignment. So you have like from now to next week to do the assignment. It is a very simple one. It's not hard. So any other
Okay, no
question?
problem, Mr. Victor. That is fine.
All right. Any other question? So I think I said I was going to share some files with you guys today, right? Okay, this is very simple storage analyst to be. So let me copy the code and put inside the so we all can have it. Why is it appearing like this? Right, please, I'm trying to set up this file so I can share it with you guys. So after that, I will just end the class. This is not appearing the way I want it to appear, but I believe you guys can understand what this contract. Here is the license. This is the Solidity version, and so here's the contract, the license, Solidity version. Here is the name of the contract, right? And here is the private state variable, and then here are the functions. So you can just go around play it. This is the one I wrote, the simple storage contract I wrote. So somebody's raising their hand, right? Any question? So you can just play around with. I'll share this link. I'll share this file with you guys. You can read all this and understand very well how to write and deploy a smart contract on a Linux IDE. Here's the permission, please. I cannot edit it. You can only read. Can't edit it. So copy the link and put it there for you guys. And then there's something else I want to share with you guys. Okay, initially I said I was not going to share this file with this constructor. The reason why you need constructor in your listing, but I'm just going to share it with you guys. This is the constructor. Constructor. Thanks, yeah. Okay, yeah. It is not there. So the rest of you should go and read more about constructor and why we need it. Why we need it. So I will share this file too. So guys, that is it. If there's any question you can ask, if there's no question, then I'll end the class. Okay, Johnson.
Okay, so sorry, sir. Please, it's just one quick question on this remix ID because I know you can publish your code just like VS Code to GitHub, but I don't know, my remix is not publishing the code. In case of the assignment submission, that's why I'm asking. How do
If
we
you
do
have,
it on remix?
if you have set up your environment, coding environment, you can push it to Git.
But mine is not going to show. I'll just check it. Thank you.
All right. So any other question from anybody? If there's no question, then we have come to the end of today's class.
Sir, please, when are you submitting the assignment?
That depends on please, it depends on the submitter. I will go through the assignment. But for me, in our next class, you guys are presenting assignments to me.
Okay.
So I would like to ask questions and know if you wrote if you guys wrote the code yourself, or somebody did it for you, or AI. So in the submit of the want to submit the assignments to them. Yes, right. All right. So in absence of any other question, we can end today's class with this. So goodbye. Have a great weekend ahead. Practice, please. Thank you. Bye bye, guys.
Thanks, everyone. Bye for now.